In figure 6.23, blocks A and B have weights of 44 Newton and 22 Newton respectively. A, determine the minimum weight of block C to keep A from sliding if mu S between A and the table is 0.20. Okay, let's answer question A first. So we are given that our mu S here is equal to 0.20. Okay, and we need to find out this one here. A, determine the minimum weight of block C to keep A from sliding. So that means that we have the system here is in stationary, right? Is in stationary state, and that means that the acceleration of the system is equal to 0 meter over squared second. Good. And now let's draw all the forces that works on A and B, right? I will start from this B here. And here, obviously, we have the weight of B pulling it down. So I will have this one here is the weight of B. But then this is pulled up by the tension of the rope, right? So we will have this one here as T. Good. And this is the only force that works on this mass B here. So we can apply the Newton's second law. Sigma F is equal to the mass times acceleration. And remember that we have no acceleration here, so I will have 0. Okay, and that will equal to 0. And if we imagine this is moving, it moves down, right? So I want this side here to be positive. So I will have WB here, weight of B minus T, and that will equal to 0. Or we can isolate for T here. T is equal to weight of B, but that means that we have mass of B times G. So we will have our T here. Oh, we are already given the weight of B, which is 22 Newton. Okay, so I have T here is 20 Newton. We don't need to find out mass times gravity. Okay, now we have our T here. Let's draw the forces that works on A here. And here we have this A here pulled by this rope, right? And that rope has the tension of T, but that is on the opposite of this because this is the reaction force, right? And then because we need to keep this stationary, and the one that keep is stationary is the force of the friction, right? So we'll have FF here. And then what else that we have? We have the weight of A pushing this down. So I will have WA. But here we also have the weight of C pushing this down, right? So we'll have another weight, WC. But then here, the force of the table pushing the mass up, right? So we will have Fn here. So we will have Fn. And we need to remember that force of the friction here is equal to mu s, static because it is stationary, multiplied by the force of the normal force, Fn, right? But then we don't know this yet. So we need to find out it by looking at the y-axis here. So we will have the sum of the forces on the y-axis, and that will equal to the mass multiplied by acceleration in the y-axis. But again, because they are stationary, this one will equal to 0, right? Now, the one that is positive is Fn. Okay, and then we need to find out what is WC and WA, right? So I will have Fn minus WA, weight of A, then minus weight of C. That will equal to 0. Good. Okay, now what is Fn? Fn is unknown, right? So I have Fn is unknown. And then weight of A, that will be 44. Okay, so I have minus 44. And then minus WC. Okay, we are looking for that. And that will equal to 0. And now we will have Fn minus weight of C, that will equal to 44. Okay, let's keep it as equation number 1. This is from the y coordinates. Okay, now let's do the x coordinates here. So I will have sigma f on the x coordinate, and that will equal to the mass times acceleration also in the x coordinates. And then this ax is equal to 0, right? Because they are stationary. And so we will have t here as the positive force, and then minus ff, okay? And that will equal to 0. What is t? T is 22. Good. And then minus ff, the force of the friction here, that will be mu s times fn. Okay, and that will equal to 0. Okay, so we'll have 22 minus mu s. Mu s here is 0.2 multiplied by fn, and that will equal to 0. Now let's plug that in. So I have 22 is equal to 0.2 multiplied by fn, and so we'll have fn here is 22 divided by 0.2. Okay, so we'll have fn, that will be, okay, let's plug that into calculator. What is it? 22 divided by 0.2. Okay, 110. And the unit here will be in Newton. And we can just plug that into equation number 1, right? So here we will have Fn minus Wc, that will equal to 44. But then Fn is 110 minus Wc, and that will equal to 44. And we can isolate for Wc, so that will be 110 minus 44. And so we will have the weight of C here is 110 minus 44. And that will be 66. 66. Okay, and the unit here will be in Newton. Okay, and I think that's all for problem A. So this is the answer for question A. Okay, now we need to find out the answer for question B. Block C is suddenly lifted off A. What is the acceleration of block A if mu k between A and the table is 0.15? Okay, we need a new pictures for that, and we need to clean this out. Okay, now let's do the question B. Block C is suddenly lifted off A. What is the acceleration of block A if mu k between A and the table is 0.15? Okay, so we'll have mu k here is equal to 0.15, and the free body diagram more or less the same, right? But we have an acceleration here that is going down, right? Logically, this will push this down, and so this movements here is going to the right. This block will move to the right, and this block going down, right? So we can start at block B here, and I want the one that is the direction of the movement as positive side. So here I will have sigma F is equal to the mass times acceleration. Okay, and so we'll have WB, weight of B, minus T, that will equal to the mass of B, okay, times our acceleration. And the weight of B is 22. Okay, so I have 22 minus T. And then what is the mass of B? We need to find out, right? So weight of B here is mass of B multiplied by G, right? So we'll have this one here is 22 is equal to mass of B multiplied by 9.8. So we can isolate that. So MB is 22 divided by 9.8. Okay, what is it? 22 divided by 9.8. And that will be 2.24. So I have 2.24 and the unit here will be in kilogram. So I have 2.24 of A, and okay, so we can isolate that. So I have T plus 2.24A, and that will equal to 22. Okay, let's have this as equation number 1. Good. And while we are at it, we can also find out the mass of A, right? So I have the weight of A is equal to the mass of A times G, and so we will have 44 is equal to the mass of A times 9.8. And what is the mass of A? We will have 44 divided by 9.8, and that will be 4.49 kilogram. And this will helpful to find out later, right, in this block. Okay, so now let's analyze on this block here. We can have again sigma F, but this time on the y direction, because we need to find out the normal force first. And that will equal to the mass times acceleration, but this time on y direction. However, the movements only follows the x-axis, so we have no movement on the y direction. So I have 0, and so we'll have Fn and Wa canceling each other, right? So I have Fn minus Wa, and that will equal to 0. And that means that our normal force here is equal to the weight of A, but we are given that the weight of A is 44 Newton. So I have Fn here is equal to 44 Newton. Okay, and then let's do another analysis, but this time on the x-axis. Okay, so we'll have sigma F, again the net force, but this time on the x-axis, and that will be equal to the mass times acceleration here of this block. Okay, it will be pulled by this tension, so I'll have T, and then minus the force of the friction multiplied by the mass of block A, okay, and then multiplied by the acceleration. Okay, T is unknown, and then Ff, that will be mu k times Fn, right? So I have mu k multiplied by Fn, and that will equal to the mass of A. We will have 4.49 multiplied by A. Okay, so we can just plug this in. Mu k is 0.15 and Fn is 44. Okay, and that will equal to 4.49A. And then we'll have T minus, okay, let's plug this to get numerical values, 0.15 times 44. And that will be 6.6. And that will equal to 4.49 ampere. And so we have T minus 4.49 ampere, and that will equal to 6.6. Okay, let's set this as equation number 2. And then we have two equations and two variables. We should be able to solve it. Okay, and the fastest way to solve this is by using calculator. Okay, so now we have this one, and let's set this here as equation solver, which is number 5. Two variables is number 1. Okay, and now let's plug this. So I will have 1 and then 2.24, and that will equal to 22. And then we have the second equation. We will have 1 here, and then minus 4.49, and that will equal to 6.6. Okay, we have the x values here as the tension of the rope. So we will have 16.87. Okay, so I'll have T is 16.87. Yeah, 87. And the unit here will be in Newton. And the y value is our acceleration, which is we are looking for. So that will be 2.29. 2.29 and the unit here will be meter over square second. So that is the answer for question B, which is 2.29 meter over square second. So we have all the answer. This is for question A, and this is for question B. Hopefully I did not make any mistakes during my calculation. Thank you for watching and see you in the next video. Bye bye.